Всем добрый вечер. После такой очень нагруженной лекции, связанной с
Hello. There was a very busy and packed topic with mathematics and very heavy stuff. Now I would like to offer you a more relaxed presentation just to
фазинга.
take a rest and deeply into a wonderful world of fuzzing. I'm Dmitry, I work for Oxorio, and we audit smart contracts, and fuzzing
направлений.
is one of the
В основном мы делаем
one of the trends. That's what we do. We specialize in standard manual audit,
Сейчас это набирает все более и
and
более.
nowadays it becomes much more popular. So
Как это работает? На самом
let me
деле,
tell you how it actually works. This lecture is a part of a more extended practical course that I read on YouTube.
планировал показать здесь какой-то.
I was actually planning on showing you a code
как это работает
and
именно.
a practical part. I was going to take smart contracts
Здесь
and run a demo on how it works, but unfortunately
показывать слайды.
I cannot
И
plug in my laptop here, so I will be showing my slides to you instead.
лекция будет примерно вот об этом. Мы посмотрим, что такое фазинг, обсудим.
This is the lecture. We'll consider the fuzzing. What is fuzzing? We'll define invariants, which are the key elements of fuzzing testing. We'll explain you the external and internal testing, the two main phases of fuzzing. And we'll speak about different other aspects which allow us to fuzz big-scale protocols, etc. So, as far as testing is concerned, if we speak about testing, there are four main testing techniques. Unit testing is the standard thing that the developers do. Manual testing, fully automatic analysis, semi-automated analysis. And let us take a look where fuzzing belongs here. Unit testing. This is what developers actually do when they write a code. They describe
с помощью тестов описывает то, как
with tests they describe how code should operate.
такого типа тестирования.
As far as the disadvantages go, mainly it covers use cases that should be fulfilled, but those that contain the mistakes do not change. So the unit testing really helps when we very frequently change the code and we once wrote it properly and then the dependencies change and it stopped working and we define it and identify it immediately. But if our code had an error which we didn't find through unit tests and we find it everywhere, then unit tests will not help us. Practice proves that very often there are not enough unit tests and people treat them very formally and people show that there's something bad with the coverage. However, there's nothing there in coverage. Manual testing is what the auditors do.
Можно найти любой баг, но вот ребята,
they can find any bug you like.
Как бы они совершенно правильно сказали, что тестированием
they properly said
ручным аудитом занимаются
that the manual audit is done by those people who are inclined to do the mistakes.
Они обычно нанимают несколько команд аудиторов.
They hire a few auditors
совершенно разные уязвимости, а возможно,
and they find different vulnerabilities.
которые так и не
Mainly they find other vulnerabilities that cannot be found by hackers. The limitations show that it takes quite a long time and quite a lot of money. And not all of the protocols allow that, so high qualification are required. It's related to the specifics of the protocol. And as auditors, when we spend time to study the protocol, study the documentation, it takes certain time. And the weakest part
мы аудируем всегда конкретно из
is that we always
когда внесены были какие-то изменения,
audit the commit.
уже становится неактуальным.
And with changes, this audit becomes irrelevant or new audit. So it takes time and money, and we just do it with the time when the base part of the protocol somehow fixed. There are tools that allow us to fully automate the search of vulnerabilities, like, for example, Sleazer. You just run it on code with one simple command and gives you the list of all of the possible vulnerabilities. The problem of the Sleazer is that all of the vulnerabilities it enlists are generic, more like. So there are many false positives with the re-entrances. In a big code base, there will be a few hundreds of them. However, everything is done properly in actual fact. So this is the way which is not very practical, and it only works for formal and simple types of vulnerabilities that developers can fix.
И, соответственно, фазинг, то, о чем мы сегодня говорим.
So fuzzing is the thing that we are talking about, is this semi-automatic testing type, because it requires not just the launch of the fuzzer itself, but it also requires adding a certain set of features
который определяет, собственно, что мы хотим
that defines what we would like to test.
Значит, что из себя представляет фазинг?
What is fuzzing?
У нас есть какой-то набор кода, кодовая база.
We have a set of code.
We
have a code base, and randomly we generate an input, providing some arguments and parameters to the functions, and we see what is going to happen. If there is an error, the error is described in properties, and we understand that the protocol malfunctions. The smart contract approach to fuzzing is just a branching of the traditional fuzzing, which is also considered here in this particular event. And this is about testing of the software when it's launched, when it's tried to be breached with certain parameters. Smart contracts do not crash. They can be reverted. But they can be reverted successfully.
Поэтому фазинг адаптируется.
So fuzzing adapts.
Там есть небольшое отличие.
When we do smart contracts, there is a bit of a difference which we can actually discuss.
Да, вот определение фазинга.
If we have this formal approach
мы даем какие-то данные.
For fuzzing, we give certain data.
Передаем какие-то данные.
We send certain data, randomly generated,
результат выполнения программы.
and we see
сам фазер.
The results. Then we need to have the fuzzer.
Формализовать вот эти вот property, которые...
And we formalize the properties.
Значит, основной фазер, который сейчас используется, самый такой, который уже...
The main fuzzer that we use here, which is in the market, is here.
Он работает следующим образом. Мы определяем некие инварианты. Инварианты
we identify invariants. It's actually called echidna. In smart contracts, invariants are solidity functions that can represent any incorrect and invalid state that the contract can reach. Echidna tries to reach smart contracts, tries to find parameters and arguments that violate that. Like, for example, what it can be: incorrect access control. The smart contractor has the owner, and we believe that this owner cannot be changed. Echidna tries to call some methods and checks that the owner has changed, however, should not have been changed. Another bullet point, incorrect state machine. Smart contract provides a pause. At this moment, no transactions should occur, yet the token transfer occurs while the contract is paused. Another bullet point, incorrect arithmetic. When we have the limited issue of tokens, and with a set of operations, we see that there are more tokens in the system than it should be. These are the examples of the use cases where fuzzing can actually help us. And it's interesting to note that if we compare it with unit tests, we will see that unlike unit testing, we assume
предполагаем, что когда мы пишем тест,
that when we write the test,
когда мы меняем owner, да, у нас есть какой-то набор.
When we change the owner, we have a set of functions that change it, but we do not test
edge cases, которые к этому могут привести.
The edge cases that can lead to that. And Echidna helps us find these edge cases, which we never even thought of. We don't need to think about them. We just need to point out that the owner has changed, but Echidna randomly finds these functions where it states that the owner has changed. And the more complicated use cases, which is relevant for larger scale protocols, and we saw those protocols a number of times, there are numbers of functions that change the state of owners. There are plenty of owners, many rows. Following this and tracing this manually is difficult. Even the owner cannot keep it in their head. There are many components that interact. So this solution may be very, very useful. Now let's just take a look at what the code looks like. We have a smart contract token where we have the total supply and the balance and the transfer function. And we set the property which was mentioned previously. So the balance of the message sender of any user should be less than the total supply, which is local. There should not be more tokens than released in the system, and this property should remain intact. So we send Echidna these two input parameters, the contract and property that we would like to verify as input. And we assure that it does something to break this variant and define invariance. Defining invariance poses a lot of challenges for the people who only start fuzzing tests. Therefore, we have the description, a very simple transcription of defining invariance. We just formulate this in words, and the balance should be less than the number of tokens in the system. Then we describe this invariant in the Solidity language, and we launch Echidna to verify whether the invariant is violated if some of the functions of the contract are changed. There are two types of invariants. The one identified on the function level and on the system level. They are different in the complexity. Function level invariants are simple. When we two numbers, we come up with a mathematical library for addition of the numbers with a floating point. We have some representation of these numbers, and we do the addition. We associate or accumulate. This property, associative property, should not be violated. And in addition function, we can check and verify that this is fulfilled. It is simple to test. The system-level invariants are based upon the state of the contract. And they require a deeper approach, and they require
времени на имплементацию.
more time for implementation. So what we saw there, the total supply is the variable of the state. So in one function, we cannot identify that invariant. We can only identify this in the entire system. These are the invariants that define the state of the contract, and they are called system-level invariants. System-level invariant.
Соответственно, когда мы запускаем ехидну, нам нужно инициализировать нашу...
When we launched Echidna, we need to initialize our system. We have a contract, a token. So how can we do that? We can deploy it in the constructor of the test, like approximately we do it in the unit tests. We have a function there that launches the system, and we do this in the constructor. For big-scale protocols, Echidna performs very powerful optimization when we do the unit tests and the scripts that deploy the entire system. We can reuse these scripts, we can deploy the protocol in Ethino and get a JSON file with the protocol of all of the transactions. And we can feed this file to Echidna, and Echidna will base everything on this deployed protocol. It will take the state from the blockchain, it can run fork, etc. So this is a very powerful tool indeed. Unfortunately, I cannot run a demo of this tool here, but those interested will get a link which shows how it can be deployed from a terminal. It's not so complicated, actually. External versus internal testing. Internal testing is the thing when Echidna has access to all of the functions of the contract. So we inherit this contract and we get access to the functions, and the Echidna starts calling them randomly. Unfortunately, for large contracts, when there are few of them, it stops working. When we only have this token contract, we can inherit it from this, and we check the properties there, like, for example, supply, etc. But what's good in this approach is that it keeps the message sender. Echidna is an external owned account which calls the token functions here. This is what it looks like. We have a token, we inherit it in the test token. And we have Echidna total supply. That's all we need to actually test our token. And it could be any type of token, if you like. The state is described here. Any token can be added there and checked for the properties. In the transfer, if in the transfer there's an overflow, something like that, if there is something strange going on in transfer, this test will suffice to identify such an error. External testing is suitable for larger systems, so when we don't have just one contract, but there are more contracts, different routers, and auxiliary functions are called. So we cannot just inherit from one single contract. However, these systems are a bit more difficult to set up. When we work with them, we do the following. We have the contract token, and we initialize this in the testing contract, which we use as a wrap. We wrap it up in this contract, and thus we get access to all of the functions. With the external testing, we get access only to those functions that are called, like test fuzz function here calls the state function
есть большой протокол.
So if we have a large protocol with lots of points of entry, for each point of entry we get test withdrawal, etc. And we'll call the functions of the protocol. Here we can see
Sender он не сохранится. Если вот здесь вот, когда вызывал,
that the message sender will not
то у нас был
be kept here. We did have the same message sender in Echidna,
от контракта ехидны, то в данном случае
which worked from the Echidna contract. Now we will call token stake, and the Echidna contract will be here. So it complicates the testing process, making it more difficult, but this is what we have to deal with.
Теперь я расскажу про функции ехидны, которые...
And now I will speak about Echidna's functions that can actually help us simplify and optimize this process, because writing invariants is not always enough. You need to debug them. Debugging is required, because if we just simply put some invariant and if we don't find any error, it does not guarantee that there are no mistakes there. Probably we just miswritten the test. In order to identify such problems, Echidna has got cover share reports. Cover share reports help us find all of the code that was touched by the fuzzer, and it marks them. I mean, Echidna, we find whether all of the functions of the contract have been called. When we have some branching in the contract, if we have some ifs and whens in the contract, we do not enter them if certain conditions arise. For example, if we have the voting contract and the voting ends at a certain block at a certain time frame, if this time frame is not met, the certain part of the code will not be accessible, and if our invariant is put on this part of the code, it will simply not be tested. In order to find this out, Echidna will provide us with a report which will see which parts of the code it could reach and which parts of the code it could not reach. So we will adapt our test so that there will be maximum coverage. It's a similar thing to coverage in unit tests. This coverage report is based upon Echidna's function. Just hold on a second.
Функция, которая называется корпус, и этот корпус позволяет очень сильно
оптимизировать
процесс тестирования.
It optimizes the testing process. The essence here is that we call the set of functions with a random number of parameters. All these parameters may be different, and some of the parameters give us a certain result. They will increase the coverage, and some of them will lead to the fact that the test drops. Some of the parameters may be used, but they will not give us any result because there are no mistakes in these edge cases. And Echidna is a smart optimizer, and this set of tools that increase the code coverage, those that give certain result in terms of the violation of invariants, it writes them into the corpus. When we launch the fuzzer on the code base, in 80% of the cases, it will be relying upon the random items, the random values. It simplifies the search process, and it cuts down the time spent on it.
Из того, что ехидна может делать интересного.
What's interesting that Echidna is capable of.
Первая вещь, мы можем фазить смарт
The first thing, we can fuzz smart contracts without actually having access
Мы можем фазить
to the Solidity code. We can
Для этого нам нужен ABI или
do it with the bytecode. We need to have the ABI or some other interface. It doesn't really matter what's happening inside the contract, because this is where we define the properties that we wouldn't want to violate or be violated. We have a token with some transfer function. We don't know what's inside this function. We can only define that the total supply will always be less than the balance of each and every user. So we just need to identify that property, and Echidna will only call those properties in EBI, and it will work.
Вторая вещь, которая
The second thing, which is very interesting, Echidna is integrated with HEVM.
На основе чего работает фреймворк Foundry.
That's what the Foundry framework is based upon. It's very fashionable in terms of testing to use, and it contains the so-called cheat codes. The cheat codes allow you to connect to any account and send transactions from its name. They help you change the block
еще набор функций, которые очень полезны с точки
provide you with a set of functions that are really useful in terms of testing. Echidna has access to all of the functions, and it allows us to do the same things that the Foundry does. It increases the performance of testing and its efficiency. It can fork the mainnet. We can test any contract there in mainnet. We just need to provide the address and ABI. It will ask for it via code, and we can test any protocol in the mainnet. So it's a very powerful tool as well. We can do the differential testing, which is about having two libraries. One of the libraries is formally verified, like, for example, a C++ library, which does some maths, and we try to describe the same in Solidity. So the essence of our test is having all of the input data that are supported by C++, so that it gives us out the same results as the Solidity library. If they match the random data, with the extreme cases, prove that the library works exactly the same. And Echidna actually allows us to realize this case in a very simple way. So it can also call up the scripts. We consider it as an instrument of testing the smart contracts, but this differential testing can be conducted, and we can compare it with the launch of any script running on Python. For example, if our library is on Python, we can run it and compare it with our Solidity function. In the lecture that I mentioned, where the workshop was recorded, it's all demonstrated there. What else is interesting? Echidna has a parameter which is called all contracts. For example, we test a very big protocol which has lots of points of entry, lots of contracts like Uniswap, Compound, or something like that. So these protocols have lots of functions that can be called, and they are all scattered across a number of the contracts: the governance function, the voting function, the staking function, etc. So we understand approximately what we would like to test, what invariants we would like to test. But that state
он раскидан по
for
этим
which these invariants depend on are scattered across different contracts. Echidna allows us to call any functions of these contracts. So we basically send all of the code base to it. And it's done simply with one simple command, which is to write echidna dot and the name of the contract with the invariants recorded. That's all. After that, echidna will be randomly calling the functions of all of these contracts, however many there are, trying to break those invariants. The only challenge here is that to limit this amount and make this test smarter, because if echidna works with these parameters and start running tests, the invariant cannot be broken, because sometimes the situation may arise when the invariant appears in some extraordinary conditions, when some of the functions are called a few times, a few swaps were made, or the protocol was put on pause and then it was taken off pause, and then all of a sudden it so happens that total supply turns out to be less than the balance of one single user. Echidna can find such dependencies, but in order to give it a hint, to prompt it, you need to exclude all of the side cases that can prevent doing it, because it will simply increase the testing time. And one final thing which is very useful in terms of practical testing, it can be launched at a big number of cores, at a large number of CPUs. Echidna Parade, here is a tool that separates these parameters into subgroups, and at each processor, all of these functions are tested. For example, if there are 50 functions in the protocol, we can split them in the number of 5 heuristically, and in each core of the CPU it will be done separately. It works 5 or 10 times faster than on a single core, and it allows us to test it much more efficiently. Even if you launch this at one single computer, it will work faster. And fuzzing has got a specifics, so if we don't have, well, in other words, if invariant in the use case is very narrow, if it's very small, Echidna will take quite a long time to find it, because Echidna will have to run through the values of all of the parameters and all of the functions combinations. It's a challenging task. It's a challenging task which is a long-lasting one. So it depends on how much time we have. So by optimizing these parameters, we can accelerate this process, speed it up. But it works in a non-linear fashion. You need to spend a certain amount of time to write these invariants and optimize these tests. So fuzzing testing has not become a household name yet, but with time there will be requests to make sure that we add unit tests to fuzzing tests, because it actually helps us find something which is not possible to find with unit tests. I'm done, and you can ask me questions.
У нас сегодня есть конкурс вопросов, поэтому человек, который задал самый лучший вопрос.
So the best question will be awarded with a piece of merchandise.
Вопрос от Дмитрия: применяются ли нейронные сети для
Dmitry's question: do neural networks work for identifying the parameters of fuzzing?
Поскольку мы говорим про конкретный инструмент в данном случае,
if we speak about a specific tool called Echidna, Echidna does not use neural networks or any algorithms.
направление мысли очень интересное.
But it's an interesting thought you provide us with here.
Ведется разработка каких-то фазеров, которые
Obviously, there are some fuzzers used that utilize such parameters.
Выбора этих параметров, да,
Because the selection of these parameters and the selection of the arguments and function,
как бы очень большое, и нам нужны какие-то эвристики, чтобы это
it's huge, and we need to have some heuristics to limit this space. Echidna limits this, first of all, with a corpus that I mentioned. When it found the coverage expansion, we find the branches of code tested previously. Then we find the set of parameters that break invariance, and Echidna starts from them and starts mutating them.
Аргумента мутации, пытаясь найти какие-то
Trying to
параметры, которые лежат вот
find some parameters in the vicinity.
наверное, и с помощью нейросетей, но пока что
It can be done, of course, with neural networks as well, but so far I don't know much about the projects that utilize neural networks as this type of test. What about sponge invariant testing? Did you compare it with your solution? Forge. Forge also uses fuzzing, yes, exactly. In terms of its performance, it would not be very much to do to correctly compare it to. When Echidna is used, Echidna is the industrial scale fuzzing tool, and Forge is a framework where in the unit tests
параметризацию, вот, что тоже выглядит как фазинг, но
parameterization can be added, parameters can be added, but Forge is not a fully-fledged fuzzer. In terms of the performance, if we would like to increase the performance of our unit tests, if we would like to add additional edge cases, and if our cases are written using Foundry, it will be affected. But if we would like to test a big-scale system, then it would be much more performing to use Echidna for that. Is there a Medusa with a parallel fuzzing? Medusa is a new tool, like jellyfish in English, which was rewritten in an adequate language. Echidna uses OCaml, so they decided to change it. So this Medusa thing does it better. I don't remember exactly what, but mutational fuzzing as a term that you use here, I don't know this term. Probably what you mean here by mutation is the field of the parameters from which we start. So I guess Echidna works in a similar fashion. As far as I know, Medusa is the rewritten Echidna, but some of the functions were not yet added there. It does not allow you to do what Echidna does, but some of the functions are there. Medusa is a new tool that probably in some space of time will take Echidna's place. What are the good practices to create Echidna tests for big-scale projects like credit protocols and DEX?
Могу посоветовать.
I can only advise you to take a look at the repository, which creates a set of invariants for testing of a certain type of a protocol, which is specified. Like for vaults and tokens, there are sets of invariants, there may be hundreds of them already available, where we just simply put our token, and all these invariants are checked and verified. As fuzzing tests become more popular, they'll be more popular as well. These invariants are more for the formally specified protocols that operate with ERC standards, because they stipulate those properties that should be performed. If we take somebody else's protocol written by someone, we just take heuristics and invariants, but in the protocol there is a lot of additional business logic which just pushes something aside. But these practices, this repository is a very easy thing to find, fuzzing-ready invariants, called like that. So I believe that they do exist, but so far I personally have not seen them.
Вопрос от Михаила.
Mikhail's question: by doing smart contract audit, what tools do you use but Echidna? We do not use Echidna in the first place. Mainly, we audit smart contracts manually. That's what it's assumed by default. We use automated testing like Sleazer, which is simple, and the developers use it on their own as well. If we are talking about the means and tools of the automated and semi-automated nature, I think Echidna is the main fuzzer that we would like to use, but it's done by default requirement of the client. The client normally expects the result as a report by manual testing, because the fuzzer also very much depends on the specification of invariants, and it does not guarantee you this. It's one of the types of tests which helps you find some complex vulnerabilities. What makes Echidna better than Fuzzing Foundry? I answered this question. Alona is asking, why do you input random data? Normally there is mutation used. Normally the fuzzers operate with the random data, but what do you mean by random? We have the uint variable which is fed in the input of the function, and the Echidna sends their 0 max uint and some values, intermediary values. It may accumulate a number of heuristics. For example, if we have require that uint is no more than 300, and the Echidna memorizes this 300 as a number, and as a function it would put 299 and 301. It will mutate this number, it will use it as a random set of parameters and argument, and mutated values as well. Question from Dmitry: does Echidna run on video cards? It's more likely no than yes. There is a version of Echidna that runs on CPU. I don't know anything that runs on GPU. However, it's an interesting option. Another question: how easy it would be catch the side chain that prevent us from finding the chain of calls from Echidna? Chain of calls from Echidna. So I think you'd better use this corpus that was mentioned here previously and coverage. You will see where Echidna enters, which branches of code it enters, and you will see why this test does not crash, however it should. We could have started the test and we write a very simple invariant which is violated, or we can come up with a normal invariant, and we may want to correct the code and see that invariant is breached, and we change it and we start testing it and does not crash, and moving step by step we can test and verify how it works. As soon as you
он должен падать, а он не
write this invariant,
и вот как раз coverage report, он очень сильно помогает в этом. Но это
coverage report really helps you with this. It's the tool which helps you visualize the process of
Вячеслав,
the fuzzing.
острорылая акула, которого я знаю по одному чату.
Vyacheslav, with the nickname of Shark, is saying, when you do decide when you use fuzzing when the audit was ordered, only if the client pays for that.
Фазинг мы предлагаем как отдельную
Well, we offer this fuzzing as a standalone service in the audit. It requires special involvement, and we do not do fuzzing as part of a typical audit. We offer it to the customer. If they're interested, we'll do that. But we mentioned that there's a functional fuzzing when we can test
нам не обязательно тестировать весь протокол.
just one single function of the protocol. For example, when we have doubts that the arithmetic works well, so we can take the call of the arithmetic function, we can fuzz it, we can feed a set of parameters and come up with a set of parameters that should be run. Like, for example, DEX.
Какие-то вот инварианты,
And DEX has invariants that are mandatorily and need to be conducted at swaps. And we can take that and check and verify that. Invariants are simple, actually. They are described in a very simple way, so it will not enhance our load in terms of the analysis of the protocol manually. How long should you conduct this fuzzing in order not to waste a week on that? Also a question from Vyacheslav. It's very hard to answer this question. I think you should start with small limitations, with a limited amount of code in the protocol, which is interesting for fuzzing. Like, for example, a set of mathematical functions or another set of invariants where they are more clear or more critical. But fuzzing the entire protocol does not make much sense if we just put it in the fuzzer compound with hundreds of function calls which unpredictably change the state. I think there will be no much use from that. The question about where is the place for fuzzing in development is just exactly where there's place for unit tests. Sometimes there is a folder with unit tests, and right next to it the folder for fuzzer variants. It's a good trend which we very often see, and the developers, as they test their solutions, they can use fuzzing tools. It's a simple tool when the person is familiar with the protocol, when they assume the invariants, it simplifies the task. So I call the developers to use this. Next question, what kind of pipeline is used in the testing of smart contracts? It depends on developers' requirements. It depends on the approach of the tests. Very often you'd see that when there was no pipeline in the testing of the smart contracts whatsoever, and it was really a sad thing. Another question from Vyacheslav. Would you say anything about interesting vulnerability caught by Echidna? I would like to send you to the GitHub repository from Echidna, where approximately a dozen of interesting, real practice-based vulnerabilities found with Echidna are published. They helped prevent losing money in the use of the protocol. There are interesting use cases. Apart from fuzzing, there are selectors. He has read this question too fast and unintelligibly. The launch of the random selector is a related question. So I think this is an irrelevant question here. I would like to ask you to take the microphone for your question.
Спасибо за доклад. Подскажите, пожалуйста, вы упомянули, что вы фазите...
You mentioned that you fuzz some modules separately. You do not fuzz a set of smart contracts or the entire smart contract.
Искать какие-то проблемы, связанные с...
To look for some problems that are related to the state. So I think the main scenario there is the scenario when you fuzz a certain module or a certain part. I wonder, to create invariants, is there a checklist for creating invariants? Or maybe there is some kind of a heuristic-based algorithms. Maybe there's a neural network will help us with that. There is one recommendation on the slide to write invariants. You identify it in words. So what do we mean by invariants? So we are sitting here in the tent,
вариант, который мы хотим
and we assume that this tent will not crash if somebody shuts the door. So let's just check this, and somebody will send someone to slam the doors, people with different builds, somebody will just slam the window frame, but the main condition here is that this tent of ours, the house of ours, will not collapse from slamming the doors. And the contracts, we know that there is an owner, and the protocol stipulates the owner, and the owner should not be changed. It's an invariant, and as a developer of the protocol, you know about these conditions, you know about these invariants, you know what the conditions are. The total supply, the balance is always less than the total supply. It's another example. But for more details to recognize you, to recognize the invariants, I would like to send you to that seminar 4626. There is a big number of invariants to read, and looking at them, you understand what they are all about. It's all real simple. The more difficult it is to come up with a pipeline of the actual test so that we violate these invariants. This is where you need to limit the number of calls. Unfortunately, I couldn't demonstrate it here by running a demo, but you can come up to me. I will give you a link to the seminar where the demo is running, and you will be able to see that. It's very useful. Thank you very much. And I have one more question about the environment. Is it always possible to emulate the environment to cover the entire code, which is achievable? Do you mean in the case of a big protocol? Yes, maybe. If this smart contract utilizes some kind of environment so that we can simulate this environment. In actual fact, we can actually see it on the mainnet and fuzz it from that state. If we take a non-deployed protocol, Echidna has a parameter which is called the sequence lane, and this sequence is a number of calls that Echidna runs. For example, we have a Texa contract. That's where the exchange operations occur, where they take off the liquidity, and these calls are randomly changing the state of the contract. Echidna provides 100 calls before checking our property. There is 100 operations in the protocol, and after that we will be checking the invariant. It's a simulated environment. At the same time, if the protocol is deployed, we can take the real states and fuzz them. You can also fuzz the deployed protocols. So it's up to you to decide as a tester, developer. Any state can be dictated, and the environment may be very flexible. Thank you. One final question about feedback. Apart from coverage, are there any other metrics related to the data? Is there any analysis of data coverage available? Something like that. Data coverage, what do you mean by data coverage? I mean that we have a set of branches, and we selected all the possible values, all the arguments. Are you interested about the methods of increasing this coverage? Yes, but do we use the metrics that allow us to evaluate where we put some data and how many values we have analyzed? Yes, there is a coverage report there in the corpus, which shows this this in detail. In corpus,
к увеличению coverage.
all the calls are stored by Echidna, which have caused the increase of the coverage, and you'll be able to see which values
Текстовый файл.
have been put there. They can be modified because it's in the form of the text file. You can analyze them. There was a very interesting question about using neural networks. So this Echidna generated file with the random numbers could be modified.
Вот этих вот случайных
It morphs these random values, and we can feed it to the neural network, and the neural network will modify this data. It may be a very interesting approach.
Что вы спрашиваете, это нужно адресовать.
But as far as your question goes, you just need to address corpus, and corpus has all this data. Okay, thank you very much.
Да, можете, у нас компания называется Oxorio, вот, и
Our company is called Oxorio.
если вы видели, если сфотографировали
If you saw it on the slide, maybe you took a picture of the slide,
можете со мной связаться, там есть мой
you can contact me. There is an email of mine, and you can ask me further questions there.